Hello everyone. Vanakkam, welcome, namaskar, swagatam. So welcome to ECJ Squatty channel. So if you didn't subscribe to my channel, please do subscribe for all the concept related to EC. So here in this channel, in my channel that is ECJ Squatty channels, you may find many informative videos regarding EC, that is electronics communication and communication engineering. So, in this today in this video, we'll discuss about simplification of Boolean functions. So, in simplification process, there are many techniques involved. So, we can do it manually, or we can now follow many techniques. So, in that, a very basic and easy technique, that is K-map. So, today in this session, we will see about K-map. Okay. K-map technique. So in K-map, there will be like 2 variables, 3 variable K-map, 4 variable K-map, 5 variable K-map, and so on. So as the variable increases, the integrity and the difficulty and the complexity in the K-map also increases. So for example, if you see the template of a K-map, it will be like this. For example, if you take a 3 variable K-map, that is X, Y, Z. So for example, this is 3 variable K-map which has variables X, Y, Z. Then how the template will be like, the numbering follows like this: 0, 1, and 2 here, 3 here, 4, 5, 6 here, and 7 here. So generally what we will write like 0, 1, 2, 2. But here, this K-map, as it follows gray code, this will follow this numbering like 0, 1, 3, 2, 4, 5, 7, 6. After that, 8 won't come, 12 will come. Okay, 12, 13, 15, 14, again 8, 9, 11, 10. So the gray code, so it follows the gray code. How the gray code is that? Like that, this K-map follows. So if you don't know about the codes, I have uploaded a video regarding the codes. So it is the previous video. If you didn't watch it, please subscribe to my channel and please do watch that video. So if, for example, if there is a 4 variable K-map, so then how the numbering goes like this. So 4 variable means we will be having 16. So 4, na? So 4 squared, 16 sets we need to have. So the variables like X, XY, ZA. For example, if this is the code, then the numbering goes like this: 0, 1, 2, 3, 4, 5, 6, 7, and 8 over here, 9, 10, 11. So this I already mentioned here. So this is the code numbering. Okay. 12, 13, 14, 15. So the markings and the template for this K-map is this one. Okay. So this is a 3 variable and this is 4 variable. So how this K-map template and how this K-map technique goes like this. So we will take one example. So using that example, we understand. Okay, so first, for example, if we take simplify the Boolean function, okay, below Boolean function we can write. So we'll take a minterm list, okay, we'll take minterm list like, so f of x comma y comma z equals to 2 comma 3 comma 4 comma 5. So this is the question. So we have a question like simplify the Boolean function, and the function is this one. So f of x, y, z. So how this will go? So we'll see. So for this, how many variables are present in this function? 3 variables. Then what we need to do? We need to construct a 3 variable K-map. So first we need to decide how many variables are present in that function. So it is already given in terms of minterms. So there is no need to worry about it. So we need to draw one 3 variable K-map. Okay. and the variables are x over here. See, there are two boxes are there, so two only it can take two values, that is 0 1. Okay, so that's why we are keeping only one term over here. And why we are keeping y and z over here, two variables here, means here we can change four boxes are present, means we can represent four numbers, that is like 0 0 0 1 1 1 1 0. So this goes like this. See, 0 1 2 3, right? So 0 1 2 3 4 5 6 7. You may ask, like generally we'll write 0 0. So the numbering goes like this: 0 0 0 1 1 0, not 1 0. Here 1 0 won't come, because the thing is that the main theory behind this k map is like at a time there need to be a change of only one bit change need to be there. See, here it become from 0 to 1, only one bit change is there. So from 0 0 to 0 0 1, so 0 0 0 to 1, so there is only one bit change. Again, here also need to only one bit need to be changed. So what we can change? So we can change this 0, that is 1 0. So for example, if you take this one, so from 0 1 to 1 0, if you take, there is a 2-bit change is there. So that we can't write here, we can't represent here. So now what we can change? We can change to 1 1. Okay. So what is the theory behind this? K map is like we need to change only one bit at a time. So then we need to represent 1 1, after that 1 0. See, only from here to here only one bit is changed. Again from here to here only one bit is changed, that is 0 to 1. And again here to here only one bit is changed. So this is the representation of three variable K maps. Okay. So how to so now how to represent these minterms? So for example, if you see, it is 2 it is written. So we need to mark 2 as 1. And we need to mark 3 as 1. Here 4, 5. So 4, 5. We need to represent this. So this is the markings. So we have already minterms. So it has become very easy for us to represent. So just represent 1 to 2 and 1 to 3. So wherever those are present, we can do it. So now we need to do map. So use mapping only, we will simplify the equation. So we need to map. So how generally mapping can be done? So for example, if you take this as example, so we can mark these two and these two. Okay. So what does this mean? So we are mapping these two and this two. So then how the equation becomes? So now the equation becomes, so how the equation becomes? So we are mapping these two. So what we need to write? We need to write which are constant. See, for example, here x is constant. So that to 0 value. So we will be having x bar. So for this rectangle, we are writing the equation. So here, the one which doesn't change is y variable. See, y 1 1 1 0. So this z is changing now. So we need to leave it as it is changing. So which doesn't change, only y, it is not changing, that is 1. So we will write y. So this expression is for this rectangle. For this rectangle, we will write. So in between, we need to keep plus, because we are as this all the thing is only one now. So we will be writing plus. So for this rectangle, x, this one is not changing, that is x. So value is 1 now. So x we will take. So here which variable is changing? Again here z variable is changing. Y is constant, that is y value is 0. We need to put y bar. So the simplified equation for this expression, so for this expression, a simplified equation is like x bar y plus x y bar. So this is the simplified version for this. See how easy it is, how simple it is. For example, if you take a manual method, which traditional method, we need to combine it and we need to apply a lot of equations, a lot of rules, identities we need to apply. After that, we will get answer. But here, see, just mapping these two, we are getting. So that is the simplicity for this K-map. So now we will see how to map the K-map. So K-map technique, how the mapping goes, we will see. So for example, if you take 4 variable K-map, we'll take a 4 variable K-map. There you will understand a lot of things. So here, if you take, you can one quad, it will be there, quad. Uh, so all like that will be there. So how to map it, we'll see it. For example, you can map these 4 things. You can map these 4 things. So if we have all the things, then we can map like whole the thing. We can map this whole line. We can map like this, like this, like this, and we can map whole the thing. So we'll get one at the time. So like that we can map. So we can having quads, triplets, all those will get. So for example, if here is there one, then we can map these 4 things, 4 corners as one expression, we can write it. Then we can map this whole thing, and we can also map this whole thing, this whole thing. That means 1 2 3 4, 1 2 3 4. So like this we can map. So mapping techniques also very important, and there are many times to mapping also. Okay, so now we will see another example. Okay, so for example, if you have so we need to map the adjacent square. Okay, so we need to map adjacent squares. So we will see the next equations. Okay, so next we will do like simplify the x comma y comma z. This is also a 3 variable map. So 3 4 6 7. So how this goes is like we'll write one variable. Okay, 3 variable. So x y z. So how the numbering 0 1 2 3 4 5 6 7. And once if you are comfortable with this template, there is no necessary even to write this. For example, in GATE exam, you have one simplify this equation. That time if you are very familiar to this coding, then there is no necessary to write this also. Okay, so now we will write 3. For 3 it is 1. Okay, for 3 it is 1, for 4 it is 1, for 6 it is 1, 7 it is 1. So how to map this? So we can do, so for example, we have one like this, we can map, and we can leave this as it is. Like this we should not do. Why? Because we are going to minimize the equation. We want the simplification. Then we need to look at these squares which are having 1. So how we can minimize the expression, we need to see. So that time when we see, we can map these two and we can map these two. So then we will get 2 expressions only. So which is a simplified version. Okay, so like that we need to map the quadrants, the squares. Okay, so we need to map the adjacent square like this. So always remember, we need to map only the adjacent squares. Okay, so now how the expression arrives in this case, like for example, if here, so here 0 0. So here, for example, if you see this, so here in for this expression, this x is not changing. So we will write x directly. And here, for example, from here to here, which variable is changing? So y is changing. See, from 1 to it is becoming 0. So z is not changing. So that is, as it is 0, we will keep z square plus. Next for this, what it is, x is changing, right? So there is no need to consider x. So here the variable which is not changing is y and z. As it is 1 1, we can directly write y and z. So this is the simplified function equation for this expression. Okay. So like this, we will be using game. So we will see one question. Okay. So how in the exam, how they will ask. So we will see it. Okay. So we have one question like, for example, so here we have one example like, give the following Boolean function. Given the following Boolean function. So what is that function? It is f is equals to a dash c plus a dash b plus a b dash c plus bc. So what it is asking, like, express it in sum of minterms and find the minimum sum of product expression, sum of products expression. So for example, if you take so here we can to get the sum of minterms. So we to get the minterms, so we can directly go by manual method. But as we know the k-map variable, so we can directly go to the k-map. So here, as it is, see, A is there, B is there, so C. So by seeing this expression, we can easily conclude that this has three variables. That means we need to follow three variable k-map. So here the template is 0, 1, 2, 3, 4, 5, 6, 7. So 0, 0, 0, 1, 1, 1, 1, 0, and 0, 1. So how we need to put that, we will see. See, a bar, a dash c. That means a 0, c will be 1. So it may come here or here. That means what? So how to put this one? So how to specify a bar? So from this equation, when we see how to get this, see, for example, there is a chance that we can get like a0 means this one 0. So here C, only C is there. C1, that too bar is not there, it is C. So directly we need to write C. So we can represent C here or here. So how to see it? So we can keep one here. We can keep one here, one over here also. Next, A bar B is there. So A bar means it is 0. Okay, 0. B will be 1. So B1, wherever B1 will be there, see here we will get 1, and here also we will get 1. And B bar C. So A is 1. B bar is like 0. B bar 0 and C is 1. C 1 0 1. So A 1 0 1. So we will be getting 1 here. Okay. Next BC, that means 1 1. And A, it is not there, means so B 1 1 here. So it may come here or here. So these are the minterms. So like this we need to represent. So what are the minterms present for this is like 1 comma 2 comma 3 comma C. 1 2 2 3 1 5 7. So that is what we need to write. So like this we will represent the minimum minterms. Okay. Now we will simplify this. So we can combine all these four, as these are all adjacent uh, squad. We can't write like this. We can directly combine these two and we can write. Okay. So the equation becomes f is equals to, as here if you see here A is changing. Okay, A is changing, and here B is also changing. So the equation for this, it comes like C plus, and if you see here, A is not changing. So A bar as it is 0. And from here to here, if you see, C changes, B doesn't change. So B. So the function, so the simplified function will be like C plus A bar B. So this is the like this only we will simplify Boolean functions using three variable K-map. So with this, our this video is going to end. And thank you for watching. Please do subscribe to my channel for more updates and notifications. And I'll meet you in the next video. Thank you. Bye bye. Have a nice day.